So, you want to learn how to solve equations with rational exponents. Well, you're in luck because we know exactly how to do that.
You may be wondering, what is a rational exponent? Well, I have an answer for that. A rational exponent is an exponent that contains a rational number. A rational number is any number that can be expressed as a simple fraction of a over b, where a and b are both integers and b does not equal 0. For example, 2 to the 3/4 power. So, an equation with a rational exponent is an equation that contains a rational exponent. Now, before we get into all of this math, let's just remember a few things. 4 to the 3/2 is the exponent being 3 over 2, which is power over root. So 3 is the power, and then 2 is the root. And because 2 is an even number, or when any even number is being used, there must be a plus or minus when solving an equation, but not when evaluating an expression, because you can't solve expressions.
Okay, so now we're going to learn how to solve equations with rational exponents. So first, you're going to identify the base and the power the base is raised to. And now this might seem redundant for some simple answers and equations, but it'll help you in the long run. Next, you're going to isolate the base to a power. And this might already be done for you in some equations, but in others you might have to do it yourself. Then you're going to raise each side to the reciprocal power to get the base to a power of 1. And don't forget, when you're doing this, you may perform power over root, and when you're having an even root being taken, you will have two answers, a positive and a negative answer. And finally, you need to solve for x. So like I said before, in some equations this will be already done for you, but in others you'll have to continue solving for x by subtracting, dividing, multiplying. So, if we gave you this equation, x squared equals 16, what would you do normally? Well, on a test, you would just take the square root of each side, and you would get x equals positive 4 and negative 4. Now, we're going to rewrite this differently and use the steps that we used to solve equations with rational exponents. So, the base is x, and it's being raised to the 2 over 1 power. It's helpful to write normal numbers as being divided by 1 so you can see that it's really a simple fraction where b does not equal 0 in a over b. So you have x to the 2 over 1 equals 16. And what you're going to do is you're going to raise each side to the reciprocal power, which is the 1/2 power, and you'll get, using exponent properties, you multiply the two exponents to raise the base to a power of 1. And when doing so, you get x equals positive 4 and x equals negative 4. And essentially, we're doing the same thing, because raising something to the 1/2 power is the same as taking the square root of something. So let's try another example. X to the 3/4 plus 2 equals 29. The base is x, and it's being raised to the 3/4 power. Now what you're going to do is isolate the base to a power. So we're going to do that by subtracting 2 from each side, and we have x to the 3/4 equals 27. Next, you need to raise each side to the reciprocal power, so you'll raise each side to the 4 over 3 power to get the base to a power of 1. And in doing so, you get x equals the cube root of 27 to the 4th power. So x equals 3 to the 4th power, and finally, x equals 81.
Now let's take this a step further. What would happen if we had a coefficient of x? Well, it would be treated the same as everything else. The base would be 4x, and then the power it's being raised to would be the 1/3 power. So we need to raise each side to the reciprocal power of 3 over 1, and we get 4x equals 8. Then we must divide each side by 4, and we get x equals 2.
So now, this is a more complicated equation. We have 5 times x minus 12 to the 2/3 power equals 20. The base is x minus 12 because it's what's being raised to the power, it's being raised to the 2/3 power. So what we're going to need to do is start by isolating the base. So we do that by dividing each side by 5, and we get x minus 12 to the 2/3 power equals 4. And then we're going to raise each side to the reciprocal power to get the base to a power of 1. So we raise each side to the 3 over 2 power, and since we're taking an even root, there will be two answers. So x minus 12 equals plus or minus the square root of 4 cubed. X minus 12 equals plus or minus 2 cubed, which is the same as x minus 12 equals plus or minus 8. And now we need to continue on to solve for x by adding 12 to each side. And since it was an even root, there will be two answers. So we add 12 to each side, and we get x equals negative 4 and x equals 20.
This problem may look very confusing, but if you think back to the basics, it'll be quite simple. First, let's identify the base. The base is 3x, and now the power it's being raised to is the 2/3 power. First, we want to subtract 2 from each side, so we get 6 times 3x to the 2/3 power equals 150. Then we want to divide each side by 6. Now we want to raise each side to the reciprocal power of 3 over 2. And we get 3x equals square root of 25 raised to the 3rd power. And then because it's an even root, we will get both plus and minus 5 raised to the 3rd power. So we get 3x equals plus or minus 125 divided by 3. And we get x equals 125 over 3 and x equals negative 125 over 3.
Okay, so now try this one. What's the area of this shape? No, just kidding. Pause the video if you need to solve it.
Did you get x equals negative 66 and 62?
If you did, hooray! You've successfully learned how to solve equations with rational exponents. Good for you!